Hi everyone, welcome back. I want to talk about two topics that don't necessarily have to go together, but I'm going to use an example that'll make it easy to put them together. How to draw Lewis structures of polyatomic ions, and then the concept of resonance structures and what that is. All right, so let's start here. Let's draw a big distinction here for a second. Let's just start with Lewis structures of polyatomic ions. So you've seen how to draw Lewis structures in general. There are a couple of techniques for that. Either one is acceptable here. What's a polyatomic ion? So poly means many. Atomic is atoms. And of course, an ion means it has a positive or negative charge. So it's gained or lost electrons. Okay, so what are we going to do here? So really, it's the same as drawing any molecular compound Lewis structure with just one extra thing we have to pay attention to. We have to pay attention to what electrons have been gained or lost and how many of them there are, and make sure we've accounted for those in the Lewis structure. That's really it. So let's do a quick little example here, and let's look at the polyatomic ion nitrite. All right, so you have a nitrogen, two oxygens with a -1 charge. The -1 charge means it has gained one electron. So the only different step here to a regular molecular compound is when we're adding up the total number of valence electrons in this Lewis structure, or in this ion, we have to account also for the charge. So nitrogen has 5 valence electrons, oxygen has 6 valence electrons times 2 of them, and that negative charge means that it has gained one extra electron. So now we have to account for, in our Lewis structure, a total of 18 valence electrons. Beyond that, we follow the exact same process as normal. We take the least electronegative, or the odd element, and put it in the middle. Then we connect the other two atoms to make a skeleton. We then start counting up to get to 18 electrons, giving the outer elements an octet first. So we have 2 4 already in there. 6, 8, 10, 12, 14, 16, 18. Then we look and see if the inner element has its octet. It does not, 2, 4, 6. So we need to fix that situation by moving a pair of electrons in as a bond. So we have nitrogen, double bonded now to this oxygen, single bonded to this oxygen, and that's it. Because it is a negative ion, by convention, we're supposed to, but often forget to, draw brackets around it and put the negative charge outside of parentheses. So that's how you draw the Lewis structure of a polyatomic ion. Okay, why did I want to talk about resonance structures here at the same time? Well, here's why. So when we were drawing this, we decided to move this lone pair of electrons in there. But could we not equally, in that situation, have made a different choice? Couldn't we equally have decided to move this lone pair of electrons into there and gotten this molecule out as a result? So this was an interesting question when people were talking about this new idea of drawing molecules using dots and lines that we now call Lewis structures. They said, wait a minute, which way should you draw it? Is it this way or is it that way? And how do you know? What's the difference? And it was a long debate for a long time, but a few things started to become clear. We were able to study these ions and their crystals, and they were able to show that there actually is no difference between these two bonds. We don't see any difference in length. Double bonds are usually a little shorter, single bonds are a little longer, but in this particular ion, it turns out that the bond lengths are the same distance apart between these atoms and these atoms. So it looks like there are no different bonds in this molecule. It was noticed some additional stuff, like these molecules were a little more stable than we expected them to be whenever you could draw molecules two ways and had to make that choice. So someone came up with an idea, and I'll tell you right up front that it's totally wrong. But they thought, what if these two molecules actually were different, but they're flipping back and forth or resonating back and forth each other so fast that it's too fast to observe, and somehow that resonant frequency, that flipping back and forth into the other forms of it, adds stability to the molecule. Now, that was just totally made up and never had any truth to it, but that's where the name came from. The idea that we can draw, that it can flip back and forth or resonate between two forms. Again, totally false. What turns out to be true, but is really hard to draw, and that's why the old name stuck, is that these extra electrons aren't really stuck between these two atoms, that these electrons and these electrons can actually move around the entire molecule. And that extra freedom of motion around this molecule for electrons actually does add stability to the molecule when the electrons aren't stuck in one place but are free to move around and spread out over the entire molecule. That makes the atom more stable. It's just really hard to draw electrons that aren't in one location but are moving freely around an entire region of space. So we stick with drawing it this way. We call those resonance structures, and we can tell you how many equivalent ways. Here there are two resonance structures, or two equivalent ways to draw the molecule. That's what we say. That's how we count them. We know that the more resonant structure you can draw, the more stable a molecule becomes. Now that probably makes sense at this point, but I want to give you a simpler way to say this so that you don't get confused in the future. The only time you need to be able to spot this is when there are multiple places on a molecule or on an ion that you could have drawn a double bond. So we could have made the double bond go here or there. And the number of places where you could have drawn that double bond equals the number of resonance structures. So you don't have to draw them both. You don't have to think about how many equivalent ways to draw a molecule. Just if you get to this point where you could have drawn a double bond there or there, just say, okay, I'm going to pick there, and I'm going to know 1, 2. There's 2 places I could have drawn it. That means it has 2 resonance structures. All right, hope that helps.